Okay, continuing to number 6. So we have these triangles here, and our goal is to find the missing side K. So we look at this one right here. We're given the reference angle is 35, and the adjacent side is 7. What we need to find is the hypotenuse. So the function that deals with adjacent and hypotenuse is cosine. So I will say the cosine of 35 degrees is equal to 7 over K. Adjacent over hypotenuse. So now what I need to do is I need to solve this for K. So I multiply K out to each side, and I'll algebraically solve this for K is equal to 7 divided by cosine of 35. Now we don't use the arc in this case because we have the angle. All right, so we just use the regular cosine function. And you can also figure this out. Just type this in on your calculator and get the decimal, and you can just replace this with that decimal if you wish as well. So 7 divided by cosine of 35. So 8.5. So that side K is 8.5, which makes sense because it needs to be greater than the 7. Remember, the hypotenuse is going to be the longest side in that triangle. All right, so let's take a look at this one. So we have the reference angle, we have the opposite side, and we're looking for the adjacent side. So opposite and adjacent, that's a tangent function. So the tangent of 45 is equal to 9 over K. So I'll multiply that out, and I will say that K is equal to 9 divided by the tangent of 45. So 9 divided by the tangent of 45 is 9. Because the tangent of 45 is 1. 9 divided by 1 is 9. So that side right there is 9. I know it doesn't look like it in the triangle, but that's the way it works out. So once again, we did not use the arc tangent. Because we have the angle, we don't need to use the arc. All right, so let's take a look at number 7. So a surveyor wishes to determine the height of a tree. So we've got a tree. Nice little Christmas tree. The distance from the surveyor to the tree is 200 feet. The transit is 5 feet. And let's see, what is the angle? The angle of elevation from this spot right here is 45. What is the height of the tree? Okay, so this is what we're looking for. We're trying to find that. And this is the 90 right there. And so what I am going to find is I'm going to find the height. Remember this. I'm going to find the height of that tree minus the 5 feet for the transit. So I'm going to find the height from this point to that point. So when I find this height, all I need to do is add that 5 feet to it in order to get the total height of the tree. Okay? And so let's see here. We've got this side is 200. So that side, this is just going to transfer up to here. So I've got opposite and adjacent. Once again, that is a tangent function. So the tangent of 45 is equal to h over 200. Multiply 200 out, and you get 200 times the tangent of 45 is equal to h. Now we can shortcut this because I already told you in the previous problem that tangent of 45 is 1. But if you don't remember that, that's okay. You can type it into your calculator. So the tangent of 200 times the tangent of 45 is h. So h will equal 200. We need to add the 5 feet for the transit. So the height of the tree is 205 feet. Okay? In these types of problems, make sure that you think about the height of the transit right here, or any other thing that you need to add into it. But the test question will be almost identical to this one. All right, so let's take a look at number 8. Okay, number 8, we've got to figure something like this. Well, it's not a very good way. Okay, so we're looking for this angle and this side. We're given this as 7, this side as 8, and that side as 10. Okay, one thing I didn't mention, did I? No. These are 90-degree angles right here. We're just going to make that assumption. So what I need is, I need to figure out, so this height right here is 8. So if I draw an imaginary line there, make that. So we're looking for this triangle. Now, if this is 7 and that's 10, that means that this is going to be 3. And this will still be 8 right there. So we're looking at that triangle right there. So how can we find, it doesn't matter which you find first. Let's find the angle first. So what we have here is an opposite side and an adjacent. And that's going to be a tangent function. So the tangent of angle 1 is equal to 8 over 3. So I'm looking for the angle and I have the ratio, so I'm going to say the arc tangent of 8 over 3 is equal to angle 1, and that is, oh, I forgot the little 1 right there. So arc tangent 8, 3, 69.4. So that angle is 69.4 degrees. Now, how do we find x? Well, we could use the Pythagorean theorem, but now that we know this angle, we can also find it using a cosine function using that side, or a sine function using that side. However, probably the better way to do it would be to use the Pythagorean theorem, because 8 and 3 are not rounded. 69.4 is rounded. But you could still use it. So the Pythagorean theorem says that x is equal to 8 squared plus 3 squared and the square root of that. So 64 plus 9 would give me, what, 73? What is the square root of 73? My calculator says it's the square root of 73. 8.54. So that is the side x. Okay, now number 9 is one that's a little bit different. I have to get my template out here if I can. Let's see, let me get it right in there. Try to do this as best I can. Oop, I missed something there. I just ignore that part right there. Can't erase it. Okay, so our sides are 10, 10, and 10. And I know it's not accurate, but let's imagine that all these sides are the same. We have to think back now. When all of the sides of a triangle are the same, it's an equilateral triangle. Now, what do we know about an equilateral triangle? All of the sides are the same, and all of the angles are the same. If all the angles are the same, we take 180, divide it by 3, and we get 60. So every angle is 60 degrees. Okay? Now, so that's just something that we just, without even looking into the problem, that's just information that I know about this triangle. All right, so let's look at what the problem says. It says, what is the diameter of the largest circle that will fit? So I need to know what the diameter is. So here's the radius. So I need to know what the distance all the way across is. Well, we can find the distance of the radius, and then we can multiply that by 2. So let's imagine here, what if I take, here's the center, and I draw a line out to that tangent point right there, and then another line out to that tangent point right there. This is going to be 90-degree angles right there. And I can draw this right there. What I want to focus on right now is one of these triangles. Let's just focus. They're going to be the same because this distance and this distance are the same, or I mean this distance and this distance. And the distance from here to here is the same, and as well as the distance from here to here. And of course, they share that side right there. So let's focus on this triangle. Now, 60 degrees cut in half is 30, so that angle right there is 30 degrees. What is the length of this side from here to here? Let's go back over to here. The length from here to here is 10. Okay, so from here to here we know is 10. So the distance from here to here, even though it doesn't look like it in this picture, the distance from here to here is halfway. And that's true about all of these. So you take this tangent point, from here to here is 5, from here to here is 5. From here to here is 5, from here to here is 5. So the distance from here to here is 5. All right. Now, what are we looking for? We're looking for this side right there. That is the radius from here to here. All right. So to find that, it looks like I've got another tangent function. So the tangent of 30 degrees is equal to x over 5. Then I multiply the 5 out. So 5 times the tangent of 30 degrees is equal to x. And I'm almost out of time for this video. So 5 times the tangent of 30 is 5 times the square root of 3 over 3, or 2.9. So 2.9 is the radius. So twice that would be 5.8. So the diameter will equal 5.8.